Strip away the mythology, and a transformer's architecture is a struct of 9 integers. This is Quen3, 0.6b, the chapter's reference model, verbatim, a vocabulary of 151,936 tokens, vectors 1,024 floats wide, the same block repeated 28 times, 16 attention heads sharing 8 key value heads. Everything between typing a question and reading the answer live in one zig file, you can read top to bottom. And here is that file doing all the work. One embedding lookup turns token IDs into vectors. A loop runs 28 identical layers, grouped query attention, then a SWI GLU feed forward, each block adding its contribution back to one residual stream. Rotary embeddings inject positions inside the attention call. A final norm, one last matmul, and out come 151,936 scores, one per vocabulary token. That is the entire architecture. Now the one idea worth going deep on, the KV cache. Generation is a loop, predict a token, append it, run again. Done naively, every new token recomputes everything about the prefix. But causal attention makes a promise. Position P's keys and values never change once computed. Later tokens cannot influence earlier ones. So cache them. Each step projects only its new tokens, appends their keys and values, and attends over the cached prefix through a zero-copy view. Every matmul now runs on one row, however long the conversation gets. Constant work per token, plus one scan of the cache. That splits inference into 2 regimes. Prefill the whole prompt at once is matrix work, every weight reused across rows, compute bound. Decode 1 token per step turns each matmul into matrix vector. Every weight byte streams from RAM for a single use, bandwidth bound. The cache costs about 112 kilobytes per position here, and sharing 8 KV heads among 16 query heads is exactly why it isn't double that. It's check 2, verify cache proves cached equals uncached, step by step. Time to hear it talk. 3 steps straight from the README. Clone, download Quen3, 0.6b in Q80 chat. Release fast is not optional in spirit. Debug builds run 10 to 50 times slower. And there it is. The tokenizer, 28 layers, the cache, the sampler, streaming an answer, token by token on a CPU. The chapter has everything this video skipped: row PE's rotation algebra as a runnable test, the sampler, chat templates, mixture of experts, every claim pinned to a file and line. Next time, inference tricks. We make this faster without changing a single answer.